So today I want to talk about something from Meta AI that shows a totally different kind of intelligence taking shape. It's not built around generating text, and it's not chasing better word prediction. Instead, it just drops the whole idea that intelligence has to revolve around language and focuses on predicting meaning directly. It's called VLJA, and it just might be a glimpse of what comes after the LLM era.
Okay, so let's get right into it. We have basically accepted this core assumption. For an AI to understand the world, it has to be able to describe it in words. But this new architecture, VLJA, suggests that text is actually a bottleneck. It's an inefficiency we might not have to live with. And by pulling word prediction out of the training loop, this system does something pretty radical. It signals a potential end to the large language model's total dominance over visual perception.
To really get this shift, you have to look at how most vision language models work right now. You show them an image or a video, give them a prompt, and what do? They start generating text, one single token at a time. They predict the next word, and then the next word, and then the next word. It works, sure, but it has some really serious hidden costs.
And this right here is the perfect illustration of the problem. Imagine asking, what happens if I flip this switch? Well, to you or me, the light turns off, the room gets darker, and the lamp goes dark. They all mean the exact same thing. But for a token-based model, those are three completely different strings of text it has to learn. It wastes a ton of energy modeling all these surface-level language variations instead of just getting the core underlying idea.
This whole token-by-token thing is it's slow, it's awkward. And for anything that needs to understand what's happening in real time, live video, smart glasses, robotics, it's a huge problem. You can't really know what the model is trying to say until it's finished generating all the text. The actual meaning, the semantics, only shows up at the very end of the line. And that adds latency and just burns compute.
And this is precisely where VLJ takes a hard left turn. Instead of predicting words, it predicts something called embeddings. Now, these are continuous vectors that represent meaning directly, not just the words on the surface. And here's the key. During training, the model never even tries to generate text.
So what exactly are these embeddings? You can think of them like a GPS coordinate for a specific meaning, right? Instead of describing a location with a bunch of words, you can just give it a precise point on a map. VLJ does the same thing for ideas. It maps both the video it sees and the question you ask to a single point in meaning space. This turns a really messy problem with tons of possible right answers into a clean, simple problem with one single target.
The whole system is built from four main parts. First up, you've got a visual encoder that takes in video and turns it into visual embeddings. Next, there's a predictor. This is the core of the whole thing. It takes those visuals and your text query and predicts what the answer's embedding should look like. Then there's a Y-Encoder, which turns the correct answer into that target embedding during training. And finally, a Y-Decoder, which is fascinating because it's not even used during training. It's only there at the end to translate the final meaning back into text when a human needs to read it.
This quote really just nails the philosophy here. The model's job isn't to become a good writer. Its job is to understand. The error, the loss, it's all calculated directly in this meaning space, not in token space. And that one change just cuts out a massive amount of unnecessary work from the system.
But, does this idea actually work in the real world? To find out, the researchers ran a really rare and direct comparison. They kept almost everything the same vision encoder, the same data, the same number of training steps. The only thing they changed was what the models were being trained to predict.
And the results are, well, they're pretty stunning. The standard token-based model used a huge 1 billion parameter language model. The VLJ version, its predictor was only half that size, around 500 million parameters. But just look at the performance. After the exact same amount of training, VLJ more than doubled the video captioning score and was way more accurate in classification. This is a case where less is genuinely more.
And this isn't some trick that only shows up at the end of training. No, the performance gap starts to open up really early. After just 500,000 samples, the embedding-based model starts to pull ahead, and that gap just keeps widening. That's not just better performance. That is a fundamental structural advantage.
The story gets even better when you get to inference time, especially with video. See, because VLJA is producing this continuous stream of semantic embeddings, you can just watch how the meaning changes over time. If the meaning stays the same, you don't do anything. But if there's a big shift, that's when you generate the text. They call this selective decoding.
And here's where we see a massive payoff. Imagine you're captioning a long how-to video.
A normal model might just generate text every single second over and over. To get the same quality, VLJA only needs to generate text once every 2.85 seconds. That is a nearly threefold reduction in really expensive computations. For any real-time system like robotics or smart glasses, that is an absolute game changer.
And this architecture is just incredibly versatile, looking at zero-shot performance across a whole bunch of video benchmarks. The base VLJA model, which was only trained on about 2 billion samples, it outperforms established giants like CLIP and SIGLIP2. And get this, some of those models were trained on up to 86 billion samples. That's over 40 times more data, and yet the more efficient architecture still wins. And maybe most impressive of all, they tested it on a world modeling task. The model had to look at two images and choose which action caused the change between them. VLJA hit 65.7% accuracy, setting a new state-of-the-art. This suggests that predicting meaning directly might actually be better for understanding physical cause and effect than trying to describe the world in words first and then reason over that text.
So what does this all mean for the future of AI? This isn't just another small improvement. It really represents a potential shift in the very foundation of how we build intelligent systems, moving from just modeling words to actually modeling worlds.
So where does this really matter the most? Well, for any problem that's heavy on perception, especially those involving real-time video, this approach is just a natural fit. We're talking smart glasses, robotics, navigation, live planning, all these areas where the token bottleneck has been a huge roadblock.
Ultimately, the big takeaway is this. The center of gravity in AI seems to be shifting. It's moving away from language and towards pure meaning. And in this new world, words, they just become an output option, a way to talk to humans, not the core mechanism of intelligence itself. For perception, the case is pretty clear. This approach is more efficient, it's more direct, and it leaves us with one last really fascinating question. What happens when our most advanced AIs stop spending all their time learning how to talk and start, fundamentally, learning how to